Section 13.2, angles of rotation. Please write down the essential question. How do I draw angles in standard position and find coterminal and reference angles? All right, scroll down here. We're going to talk about positive rotation and negative rotation. And when we are talking about things down here, positive rotation. So I'm going to read below here. An angle is in standard position when its vertex is at the origin. Let me get a pen here. This is the origin. This is the origin. And one ray is on the positive x-axis. This is called a ray. This is called a ray on the positive x-axis. The initial side of the angle is the ray on the x-axis. This green is the initial side. That is always the initial side. The other ray is called the terminal side of the angle. So that's the red on each of these. As you can see, but I'm going to scroll down because I don't want to repeat myself here. An angle of rotation is formed by rotating the terminal side and keeping the initial side in place. So the initial side stays and we rotate the other side. If the terminal side is rotated counterclockwise, so I'm going to write that. This is counterclockwise. The angle of rotation is positive, as you can see right there. If the terminal side is rotated, so that's counterclockwise. If the terminal side is rotated clockwise, the angle of rotation is negative. The terminal side can be rotated more than 360 degrees. So let's write this. So over here on this one, this would be, oopsie, it's not letting me write this here. This would be clockwise. Let's write that. And then you can see there's our angle, and it's negative. So counterclockwise, I think, you know what I think of it as? You're going up, positive. Clockwise, you're going down, negative. And here it just said the terminal side can be rotated more than 360 degrees, because as you can see here, we started, and we're going to talk about this in the next page. We started here at the initial side and we went up. So counterclockwise, we did a full 360 and went a little bit more to get our terminal side, which we traveled a full 390 degrees. Okay. So here we go. A little tip. 360 degrees rotation is a complete rotation. 180 degree rotation is 1/2 of a complete rotation. Number 1, draw an angle with the given measure in standard position. So when we talk about standard position, remember, like we said on the last page, an angle is in standard position when its vertex is at the origin. When its vertex is at the origin, and I'm going to go back so you can see what I'm talking about. Its vertex is at the origin and one ray is on the positive x-axis. So always refer back to that if you need to recall what standard position means. Positive x-axis, right there. So all of these are starting in standard position. That's what that means. All right, so now A is a positive. That means I'm going to travel up. The negative, there's no such thing as a negative angle. All that means is the direction you're traveling to calculate it. So we're going to start anywhere along here. I usually start about right here because you might have to do a bunch of different circles around, and you'll see that on B. So if I'm going to travel, I know that from here to here is 90, from here to here is 180, and I know I have to travel a little bit more to get to 210. All right there. And there is our angle. That's how you draw an angle with the given measure in standard position. Now, and we knew we weren't going to keep, we knew we were not going to keep going. Just grab my calculator here to explain something to you, because there we go. Because if you think about this is kind of an estimate, but I know that from here to here is 180, and I need to travel an additional 30 degrees to get to 210. On this one, well, pay close attention here, we're getting to 1020 degrees. So I wrote down below how we're going to get there. We're going to do a full 360, and notice I'm going to loop over here because I have to keep going. Then I'm going to do another 360. So I took care of this, I took care of this. And now I'm going to do a 180, which is going to land me right there. I'm going to do a 90, which is going to land me right there. And then I'm going to go an additional 30. And that's where I end, and that's where I draw my terminal side. All of these add up. This is how I separate it to add up to 1020. Now on the part C, we're going the other direction. We're going negative. Negative means I'm going down. So I'm going to travel, here I go, this way. That's the 180, and add an additional 90 and a little bit more right there. And there we go. We're not quite at 360 on that one. But again, the direction I went, that refers to the negative. Coterminal angles are angles in standard position with the same terminal side. For example, angles measuring 120 degrees and negative 240 degrees are coterminal. Remember, the negative does not mean there's no such thing as a negative angle. It's the direction. So as you can see in this picture, from here going up counterclockwise, that measures 120 degrees. Whereas if I go the other direction, here all the way around, that measures 240 degrees. It's negative because I'm going the other direction. What we're going to find is there are infinitely many coterminal angles. One way to find the measure of an angle that is coterminal with an angle theta is we're going to add or subtract integer multiples of 360. All right, example 2. Here we go. Find the measures of a positive angle and a negative angle that are coterminal with each given angle. These you're going to find are very, very easy. All you're going to do is take your angle given and you're going to add 360. Think what that's doing. That's doing a complete circle around, and you're ending at that same terminal side. So 88 plus 360, that's 448 degrees. And then you're going to take 88 degrees and you're going to subtract 360, and you're going to get negative 272 degrees. That's all you're doing. Now, in example 3, you're going to find out that we may have to either add more multiples of 360 or subtract more multiples of 360 so that we can get a positive and a negative. So here we go. You're going to start with your given angle again, and we're going to find a positive and a negative angle that are coterminal with this given angle. That means they share the same terminal side. So I'm going to add 360. Well, that's just 860. But when I take 500 degrees and I subtract 360, I still get a positive. So then I just have to subtract another 360, and now I have my negative. Remember, there are infinitely many coterminal angles. All right, we're going to save example 4 for class, and now I'm going to go down here. For an angle theta in standard position, again, standard position means your vertex is right here at 0, 0, and your initial side is on the positive side of the x-axis right there. The reference angle is the positive. Here, let's highlight this. It's positive. It's acute, positive acute angle formed by the terminal side of theta and the x-axis. That is important. And remember what acute means. Acute means it is less than 90 degrees. I'm going to write that. Acute means less than 90 degrees. So what I'm going to tell you, when we're finding reference angles, I'm going to want you to draw the angle like we did in example 1, because that's the best way to determine what your reference angle is. I can't give you a for sure of, yes, you subtract 360, yes, you subtract 180. A picture is the only thing that's going to help here. So as you can see in this example, they drew the angle. There's the terminal side. So then the reference angle is not that, because that angle is greater than 90. The reference angle has to be in here because that's less than 90. All right. Example 5. Find the measure of the reference angle for each given angle. So first of all, let's draw our picture. Here we go. There's our initial side, 105. Well, I'm going to travel up 90 and a little bit more. There it is. Drew my angle. And recall, let's go back. A reference angle is positive, acute, and it's formed by the terminal side and the x-axis, right? So if I highlight this, this is the terminal side and this is the x-axis. So our reference angle has to be right here in the red, because 105, which is this is 105. The reference angle is not 105 because that's greater than 90 degrees. So the reference angle always has to be in between the terminal side and the x-axis, right here. Terminal side and the x-axis. Doesn't have to be on the positive side of the x-axis like the initial side is. So how do I find? There we go. That's our reference angle. And how do I find that? Well, I know that from here all the way to here is 180. And if I take this whole distance from, let's change my color, from here all the way to here, which is 180, and I subtract off this stuff up there, which is 105, I'm going to get this part right here, which is 75 degrees. All right. So our reference angle is right here and is 75 degrees. That is our answer. On B, we're going to go the other direction because it's a negative. So when I draw, again, here is my initial side. I'm going to travel 90 and a little bit more. There we go. And again, remember, our reference angle has to be acute, it has to be positive, and has to be in between the terminal side and the x-axis. So if I look at this, there's my terminal side. There's my x-axis. It has to be over. Oh, that's not what I wanted to do here. I meant to get a different color. It has to be right there. Reference angle. It cannot be over there, cannot be over here, because that adds up to 115, which is greater than 90. So how do we find a reference angle? Well, again, I know that this whole distance, yeah, I know I'm traveling down, so it would be negative 180. But remember, reference angles aren't negative. So that whole distance is 180. And I'm going to subtract off all of that, which is the 115. And when I take 180 minus 115, I get 65 degrees. So that is acute. So it's less than 90. It is positive, and that is our reference angle. So when we're finding our reference angle and you're doing the subtraction, you don't worry about the negative. The negative only tells you how to draw your angle. Negative there means I'm traveling down. And part C we will save for class. And this next part we're going to be doing in class. And here's your video questions. Please do them in your notes.